right, let's do an example problem involving forces and acceleration and solving for the forces involved and also for the acceleration acting on the object. So we have this system here, an applied force of 50 newtons is being used to accelerate an object that weighs 80 newtons. We're told that there's 10 newtons of friction, and we want to find normal force, net force, mass, and acceleration. Lots of things to figure out here. Honestly, you'd only usually be asked to find out one thing in a problem, but we're going to practice everything in this one example problem. So the steps are largely the same as what we've seen before. We're going to first just draw what's happening here. So we have something, here's our drawing, here's our object, it's a square, whatever, and it's being pushed by 50 newtons. We know we have a friction of 10 newtons. We know it weighs 80 newtons. And okay, so we've got our sketch there. If I draw my circle around it, we can use that to start recognizing what forces are acting on it. We have something in contact here and something responsible for the pull or the push that's sending it 50 newtons that way. So my free body diagram is going to have several vectors acting on it. It's going to have the force of gravity, that's mg, which is equal to 80 newtons. Weight is mg. So we've got it in there. I wrote that 3 different ways, but those are all the exact same vector. Then I have another force acting on it, the 50 Newton vector. So it would be, I don't know, something like that. And this is the force applied, which would be 50 newtons. And then I have 2 more forces. I have a very small force going this way, because 10 is much smaller than 50. So there's my force of friction, which is equal to 10 newtons. And then I have my normal force. And I'm not going to assign a value to that yet, but I am going to say normal force is going straight up because it's perpendicular to the surface. That's what the word normal means in mathematical terms. It means perpendicular. So I've got my drawing, I've got my free body diagram. I just need a coordinate system real quick. Let's say that up is positive and right is positive as we go into the symbols. So the symbols that we need a symbol for each force. So we're going to just go down the list. Normal force, friction, force applied, and weight. Then we also need something for a variable for mass and a variable for acceleration. And this takes care of all of our new variables for this new unit. And then we'll also often need the same list of kinematic variables that we've used in past class or in the past unit. So I've got all my variables there. Let's start filling in what we know. I know that friction is 10 newtons. I know that the force applied is 50 newtons. I know the weight is 80 newtons. I know that, I don't think I know anything else. Here's what I do know. There's actually no motion described in this. I don't need any of these variables here. But I wrote them there because we will start needing them very, very soon. So get in the habit of keeping these variables in mind because they will still come up. What I want to point out, though, is that the acceleration you figure out here is the acceleration you find here. So often we're going to be using one of these sets of equations to find acceleration, and we'll put it into the other side, that either finding acceleration from the motion equations and using it for forces, or finding acceleration from forces and using it with kinematics. Okay, so we've described some variables. I think everything else here are things we want to know. We want to know what normal force is. We want to know what mass is. We want to know what acceleration is. Oh, and I didn't write it down, but we also want to just know what is the net force. So then we have equations, and our list of equations is going to be getting bigger and bigger and bigger. I'm not going to bother, well, I'll write them all down this time. So one of the new equations that we have is acceleration equals the sum of the forces over the mass. We have another equation that's just the sum of the forces is equal to the sum of the forces in the x plus the sum of the forces, in the y. We have our various kinematic equations that I'm definitely going to skip writing this time. And then we have things like weight equals mg, which is another useful one that we're gonna use pretty often. So we have those equations to work with, and I can't tell you guys always start with this one or anything like that because it's going to depend on the problem. Big difference between physics and past math classes you've taken is that there's not going to be a set problem-solving strategy. You have to be adaptable and comfortable enough with all of these things to solve problems that look different than ones you've seen before. The physics principles will stay the same, the equations will still exist, but you have to find the right ways to use them. So I'm going to start actually with setting up my sum of my forces equations. Let's do the sum of the forces, I'll do it in red. Sum of the forces in the x direction is going to be 50 newtons minus 10 newtons, because you see that that 10 is going the opposite way. So I actually have a net force of 40 newtons in the x direction. In the y direction, I can already say that I know that the sum of the forces has to equal 0 because there's no acceleration happening on this box vertically. It's just staying on the surface. We know that because there's no forces pulling upward. There's no reason for it to be leaving the ground here. So it has to have a net acceleration of 0, so the net force has to be 0. Which means that I can write out the sum of the forces. The sum of the forces in the y direction, that would be my normal force minus mg equals 0. And since I know that my weight is 80, my normal force has to also be 80 in order to make that 0. Okay, so we just figured out that one. If we have no net force in the horizontal and we have 40 net force in the x, then we know this is going to be 40 newtons going in that direction. So there's our net force. Now that we know our net force, actually, let's figure out our mass. Let's go here. We know that the weight is 80, and that equals m times g. So if we want to get m by itself, we divide both sides by g, and we find out that m equals 8 kilograms. So now we know our mass, and now I can go to this equation that I checked earlier, but now I'm ready to use. And we can say that our acceleration is going to be our net force, that's 40 newtons, over our mass, that's 8 kilograms, which is 5 meters per second, which would be used here, but we just don't need it for anything in this problem. So that's how we would do an acceleration problem. Yeah, that's it. That's all I got.